Hey students, let's do a little more practice with the using symmetry to plot points. So as you can see, this one's already completely completed. Basically what you do, friends, is you use the axis of symmetry, that x equals -1, that's already made, and any coordinate point on the left is going to have a buddy to the right, any coordinate point on the right is going to have a buddy to the left. Each of the blocks has a half, so if you count how far it takes you to get to the axis of symmetry, you just copy that distance back to the other direction and you'll get your coordinate point. So in this case, we have -4 and 28. It takes 3 to get to -1. Look at this, -4, -1. It takes 3 to get there, so that means it's going to take 3 to copy its buddy over here on the right. Again, notice I don't have it highlighted. Give me 1 second here. Notice all of the symmetric y values, all of the symmetric coordinate points have the exact same y value. So look at that, 28, 28. These dudes have 17. These have 8 and 8. These have 1 and 1. These have -4 and -4. And then there's the axis of symmetry. There's the vertex all by itself. So points that are symmetric to a vertical line, which is the axis of symmetry, have the same y values, which I just highlighted, because they're equidistant. They have the equal distance to that line of symmetry. So take your time, count the distance to the line of symmetry, and then copy and paste it to the other side. A little bit of logic here. Points that are symmetric to a horizontal line have the same x value. So if you're copy and paste left and right, you got the same y. If you happen to be copy and paste up and down, you'd have the same x values. Just a little nugget of information there. How can you spot a vertex from each table? Well, this is kind of like we've seen before with the other tables. If you match up the y values, going from what we just said, same y values, okay? If you match up those y values, the vertex will be in the middle of all of the matching. So as you can see here, 20 and 20 match, 15 and 15 match, the vertex is right in the middle. The next one is kind of a goofy one. We don't actually have the vertex, but we definitely have some clues to it. We have -8, -8, -18, -18, -22, -22, but we don't actually have the vertex, okay? But we know if it's going to be in the middle of these two, it's going to be in the middle of these two. In the middle of 7 and 8 is 7.5. Now, we can't really bullseye the vertex. We don't know what it is, but we can kind of guess it's definitely going to be less than -22. So if we keep going with the pattern, look at it's getting smaller, 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 smaller. It's definitely going to be less than -22. Do we know exactly what it is? Not really. But if we had the equation, we could figure it out, but we don't really have that. So we just have to do the best we can. And then the last one's pretty obvious. The -22s match, the -14s match, and then there you go. There's 1 and -10 right there in the middle. So that's how you can use symmetry to plot coordinate points and spot vertices.